Hey everyone, this is Juke with welcometotruth.com, also in tandem with clickmill.co. Thanks for being here.
Hmm.
Um, so I want to talk to y'all about irreducible complexities. And this comes from the book Darwin's Black Box by Dr. Michael Behe. Dr. Michael Behe is part of the intelligent design movement, which says that the more we study science, it seems to point to an intelligent being rather than just happening by chance, which includes Stephen Meyer, Douglas Axe, and other PhDs. Okay, an irreducible complexity is in his book Darwin's Black Box. He compares it to a mousetrap. A mousetrap has five main parts to it. See if I can remember. The base, okay, the spring, the hammer that comes down on the mouse, the catch, okay, and
The little thing that holds the cheese, is that the catch?
I think that's the catch, and then the bar that comes down.
The
No,
hammer.
that's the hammer. Anyway, there's five parts. I guarantee it. Um, but the point of an irreducible complexity is that if you take away any one of those parts, the mouse trap does not function. And so this is very important because in Darwinian evolution, which is the evolution that they teach in our schools today, um, it's based on a step by step or gradualistic account of how all of life came to be, right? So they start out with a single celled bacteria, and step by step, through the process of random variations through natural selection, we eventually get, amphibians and frogs, and then we get, snakes and birds and humans. Okay, it all comes through a step by step process,
Can I
and
uh can I cut
yeah.
in for 1 second and just add something in there, make sure I understand you for clarity?
Mm,
So you're saying step by step. What I hear you saying it also is slow change over time. So it's not
yeah.
like it's a mousetrap and then it's like something totally different. You have to change one tiny component of that at a time. But the stipulation there is the organisms have to live at every change. So
Right.
every change, that organism has to be fully functional. So
Right.
when you change one thing, it has to be completely functional at every single step. So it's slow change over time, but the other requirement is at every minor change, all of the parts have to work together perfectly in order to continue to function. So I'll just add that in because I think that's what you're
Yes.
saying. Am I right?
Yes, and that's called minimum function. So like Brett was saying, at every step of the way, it has think according to natural selection, that organism much must have minimal function, because if it meaning it has to still be able to operate, and not only operate but have a functional advantage enough to reproduce. Okay? So natural selection is about having certain organisms having functional advantages. Those organisms reproduce and create more of those type of organisms, and the other ones who don't have a functional advantage die off. Okay, that's kind of just a quick premise of natural selection. So Darwin himself, Charles Darwin, wrote the book On the Origin of Species in 1859. Darwin himself said if it could be shown that an organism existed which could not possibly have been formed by a step by step process, my theory would ultimately be kaput. My theory would, he didn't say kaput, but my theory would be garbage. My theory would not work. Okay. So if we can show even one organism that could not possibly have evolved in a step-by-step process, meaning, again, like Brett was saying, there's functional advantage, there's minimum function, it is able to function. And um, if that can be shown that one organism did not have a functional advantage or did not have minimum function as it evolved, then Darwin's theory is garbage. Okay, so there are these irreducible complexities that actually prove that actually show that there are multiple parts to it. And if it was missing just one of those parts, it would no longer be functional, just like we talked about a mousetrap. If the mousetrap didn't have a hammer to come down on the mouse, the mousetrap would not be functional. If there was no base, if instead of a wooden base, it was made of paper, that mousetrap wouldn't be non-functional. If there was no spring, then the hammer would never spring down on the mouse. If there was no catch, then the mouse would also would not immobilize the mouse. So, and not only that, but each of those sizes, it's not only the components, but each of the sizes must be specific as well. If the hammer was too big, then the spring itself would not be able to pull the hammer down on the mouse. If the spring was too small, then it couldn't lift the hammer on. If the base was smaller, then it couldn't fit. So it's not only the components that are necessary, but it's also the size and specificity of those components in order to make a functional mousetrap. So that is what an irreducible complexity is. And we will talk about some examples of irreducible complexities. And again, if you want more examples, look up Dr. Michael Behe with the book Darwin's Black Box. And you will get more examples, which include blood clotting, which include the cilium, which include the eye, how the eye works. Those are all examples of irreducible complexities which disprove Darwinian evolution.
Can I hop in for 1 second?
Hop in.
Another reason that the mousetrap is such a good example is because you cannot change the structure of a mousetrap in any steps, because in order to add in another component into the system has to be non-functional because every component is required. So you cannot have small change over time, because as soon as you loosen up that let's just say the spring, the mousetrap no longer works. You have to have it working all of the time in order for that organism to continue to survive and pass on genes. There's no 2 generations or 1 generations where the spring doesn't work, and whatever creature this is, it has to work all the time. But you can't change the system without taking it apart to put something else in. So that's another reason why an irreducible complexity is really an Achilles heel for the slow change over time in Darwinism. And so in the next video, what we're going to do is we're going to look at here a little bit what is called a bacterial flagellum. Now, Juke mentioned some other irreducible complexities, but a bacterial flagellum is really a very ironclad example of what this is. And so we'll be talking about this microscopic organism and why it is an irreducible complexity. It is a complex organism that can have no less parts than the exact number of parts that it has, which means unless it just magically fell together like we know DNA did and the cell did, joking obviously, then it seems to point strongly to an intelligent designer, not random chance and time. So with that, we'll see you in the next video. God bless.